This lesson is on trig. So first off, we've got our basics. So sine theta is opposite over hypotenuse, which can also be written as y over r. Cos theta is adjacent over hypotenuse, which can also be written as x over r. Tan theta is opposite over adjacent, which can also be written as y over x. So if we look at this mini Cartesian plane over here, the y represents this side, the opposite. The r represents the hypotenuse, and the x represents the adjacent over here. Then we move on to special angles. These are triangles which have known sides and angles and which need to be learnt off by heart for the exam. So we have our 60-30 degree triangle. So basically they could give you, for example, here I've given sine 60, which you need to know, you need to put it as root 3 over 2 because opposite over hypotenuse. There's another triangle, which is the 45 degree triangle, which is 1, 1, root 2. And for example, if they gave you sine 45, you would need to do opposite, which is 1, over hypotenuse, which is root 2. We then move on to the cast diagram, which is the Cartesian plane. And we start labeling in the fourth quadrant, so we use CAST. This stands for cos, all, sine, and tan. This just basically means in their respective quadrants, what is positive. So in the first quadrant, we have A, which is all. So that means all of the ratios are positive in the first quadrant. Then in the second quadrant, we have S, which is for sine, which means only sine is positive in the second quadrant. In the third quadrant, we have T for tan, which means only tan is positive in the third quadrant. And then lastly, in the fourth quadrant, we have cos, so only cos is positive in the fourth quadrant over here. Then we have the little reduction formulas that go with it. So in our first quadrant, the main ones would be theta, then 180 minus theta in the second quadrant, 180 plus theta in the third quadrant, and 360 minus theta in the fourth quadrant. You can also use 90 minus theta in the first, 90 plus theta in the second, 270 minus theta in the third, and 270 plus theta in the fourth. It's important to remember, if you're going to use these ones, the second group, the 90 minus, 90 plus, 270 minus, and 270 plus, to change from, if it was sine 90 minus theta, to the cos 90 minus theta, or cos theta. But let's look at an example, and it will make more sense. So if we have sine 180 plus theta, we go to where 180 plus theta would be, and that is in the third quadrant. We see that only tan is positive here, so sine is definitely going to be negative. So we'll have our negative, and then sine theta. So basically, sine of 180 plus theta is equal to negative sine theta. So once you've found the quadrant and decided on the sine, this falls away and just becomes theta. Here's an example of a cos 90 plus theta. We go to where 90 plus theta is. It is in the second quadrant. Cos is negative here because sine is the only thing that is positive. So we know that cos is going to be negative. So we write our negative down. But because it is a 90 plus, we need to change the cos to sine. So this is the special rule. Whenever there's 90 plus, 90 minus, 270 minus, or 270 plus, the cos becomes sine or the sine becomes cos. So we first have to find the sine. Once we've found the sine of our ratio, then we're going to change the cos into sine, and this just becomes theta. So cos 90 plus theta is negative sine theta. Now I'm going to go on to a few more example type questions. Here is a Pythag problem. This is basically going to be using our trig basics to work things out. So they've said if 13 cos theta minus 12 equals 0, calculate what tan theta is. So what we're going to do is we're going to simplify this so we can just have it as cos theta equals. So we take the 12 over, it becomes positive. So 13 cos theta equals 12. We then want to take the 13 across, so we're going to divide. So it's going to be cos theta equals 12 over 13. But we know that cos theta is equal to x over r from our basics above. So then, if 12 over 13 is ultimately x over r, x equals 12 and r equals 13. It might help to draw the Cartesian plane. So we have r as our hypotenuse over here as 13. We have 12 on the x-axis. We put in our theta, and now it is easier to work out y. We're going to use Pythag. Because 13 is the hypotenuse, it's going to be y squared equals 13 squared minus 12 squared. This Pythag's meant to be up there, I just don't have space. Then y equals, we're going to take the square over, it becomes square root. You can put this whole thing onto your calculator and you get y equals 5. So now we know y is equal to 5. Now that we've got our x, our y, and our r, we can go back to what they were asking us. They wanted tan theta. Tan theta we know is y over x. We have y and we have x. So tan theta equals y, which is 5, and x, which is 12. So tan theta equals 5 over 12. This is just a basic example. They can give you a longer thing to figure out. So like sine squared theta plus cos squared theta. And all you have to do is just substitute into your little fractions. So up here to write these in place of your sine, your cos, and your tans. And then it will become a bit easier. Then we move on to identities. Okay, so you'll probably be given an equation and asked to prove it. So it will be something, something, something equals something, prove the identity. So what you want to do is you want to split the left-hand side and split the right-hand side. You want to keep them separate. You want to simplify each side as much as possible on its own until they are equal. Generally, they'll have one side being more complicated and you can just simplify the one side and eventually it'll equal the other side. So for example, you can try and make the left-hand side equal to the right-hand side without simplifying the right-hand side. But sometimes you do need to simplify the right-hand side a little bit or vice versa. But that's just an example. The things you can use in your identities, just as a side note, you must remember that sine squared theta plus cos squared theta is equal to 1. Tan theta can be changed to sine theta over cos theta, your double angles and your compound angles. Now, before I go into an example of this, I just want to go through what double angles are and compound angles are. So first, our double angles. You get the two types, the sine 2 theta and the cos 2 theta. Cos can be split into 3 different ones, but we'll get there just now. So firstly, sine 2 theta. Whenever you see sine 2 theta, you can write it out as 2 sine theta cos theta. It's just a rule. It's on your formula sheet that you can just change it, like they're interchangeable. There is a video on your paper 2 proofs where it explains how to prove this identity. Okay. So here's an example. If they gave you sine 180, you could split the 180 into 2 times 90. So sine 2 times 90. So now it looks very similar to up here. So what you're going to do is you can have your 2 sine, instead of theta, we're going to have our angle, which is 90 cos 90. A lot of the time, this will come in handy when they've given you an angle. So if they gave you, if they're in a triangle, you're working with the angle of 35, and they have given you that sine 70, then you can use sine 2 times 35. That's just an example. That's where it comes into play a lot. It's when they've given you an angle and they want you to work out the angle doubled or something. Okay. Then we move on to cos 2 theta. Now, there are three different things that cos 2 theta can equal to, and they are all on your formula sheet. Cos 2 theta can equal cos squared theta minus sine squared theta. Cos 2 theta can equal 2 cos squared theta minus 1, or cos 2 theta can equal 1 minus 2 sine squared theta. Once again, there is a video up on the proofs for all of these. Okay. Then next, here is an example. So like I said, with the 70 degrees and the 35, if you had information with cos 35 or anything with 35, you have information about it. But they've asked you to calculate cos 70. This is what you would do. You would say cos 2 times 35, because 2 times 35 is 70. Then you could use any of the cos double angle formulas. So you could have cos squared 35 minus sine squared 35, which is this. You're just replacing your theta with a 35. Or you can have 2 cos squared 35 minus 1, or you can have 1 minus 2 sine squared 35. If you don't know which one to use, try one. If it doesn't work, you can try another one. Okay. Then we move on to compound angles. So this is when you have sine and an angle plus another angle, or cos, an angle minus another angle. These are the different types you can get. So I've just used A and B, just because this is what they use on your formula sheet. Okay, so if they have sine A plus B, that can also be written as sine A cos B plus cos A sine B. Sine of A minus B can be written as sine A cos B minus cos A sine B. Cos A plus B can be written as cos A cos B minus sine A sine B. Cos of A minus B can be written as cos A cos B plus sine A sine B. A little side trick to remember these is if it has an S, they're the same sign. So sines keep their signs, they have the same sign. So if it's a plus there. If it's a minus, it's a minus there. With cos, you would change your sign. So if it's a plus here, you're going to change it to a minus there. If it's a minus here, you're going to change it to a plus there. Here is a practical example. If you have sine of 105, this can be split into special angles of 60 and 45. So it's all about identifying whether they've given you angles or whether you can use your special angles to simplify something that you can't do without a calculator. So here now this looks very similar to our first one, sine of A plus B. We have an angle plus an angle. So we're going to use our rule to expand it. So we're going to have sine of 60 cos of 45 plus cos of 60 sine of 45. Then you're going to use your special angle triangles to figure out what would sine 60 be. If you were to use them, you would get that sine 60 is root 3 over 2, cos 45 is 1 over root 2, cos 60 is 1 over 2, and sine 45 is 1 over root 2. And this whole thing simplifies to a fraction that is now cut off over here. Sorry, that is supposed to be root 6 plus root 2 over 2, I think. But you can put it on your calculator to get that answer. Then, now that we've gone over what compound angles are and what double angles are, here is an identity example. Okay. So we have sine to the 4 theta minus cos to the 4 theta equals negative cos 2 theta. So they want us to prove that this whole thing is equal. So first what we're going to do is we're going to start with the left-hand side because it looks the most complicated. So the first step we can do is factorize this with difference of squares. So this can become sine squared theta plus cos squared theta, bracket sine squared theta minus cos squared theta. Notice the difference of squares. This is a square, this is a square, they are difference. We have the double brackets, plus minus, square root the first, square root the second, square root the first, square root the second. Then we know from our identities that sine squared theta plus cos squared theta is equal to 1. So that now just becomes 1. Then from this, we can't do much with sine squared theta minus cos squared theta. So we're going to change sine squared theta into 1 minus cos squared theta, because just how sine squared theta plus cos squared theta equals 1, if you take the cos to the other side, sine will equal 1 minus cos squared theta. Sine squared theta will equal 1 minus cos squared theta. So we're going to sub that in. Then we're going to keep the minus cos squared theta. Once we simplify that, it becomes 1 minus 2 cos squared theta. We're getting closer now. This kind of looks like one of our double angle causes, but not quite. It needs to be the other way around. So we can take out a negative, and this will become 2 cos squared theta minus 1. So then we can replace this with our double angle of cos, so that will be minus cos 2 theta. Now, our left-hand side looks like our right-hand side. So you say, therefore, left-hand side equals right-hand side. And then your identity is proved. Okay, now with reduction formulas, here is a long example that we can do. And it's also including our special angle triangles. So here we have tan of 210 degrees, sine of 240, sine of 170, over cos of 100, sine of 225, and cos of 135. These dots mean times. Okay. So now we need to get this 210 into something else. We can either use double angles, compound angles, or our reduction formulas, which are from up here. It's these. You want to get it 180 minus something, or 180 plus, or 360 minus. So let's see what we can do with these. So our 210, if we want to try with, generally it's easiest to try your 180 pluses, your 180 minuses, before you try your compound angles and your double angles. So 210 can be formed by 180 plus the 30. So we're going to change tan of 210 to tan of 180 plus 30. Sine of 240 can be changed to 180 plus 60. Sine of 170 can be changed to 180 minus 10. Cos of 100, this can be changed to cos of 90 plus 10. Sine of 225 can be changed to 180 plus 45. And cos of 135 can be changed to 180 minus 45. So now we're going to get rid of the 180s and reduce them. So it's going to be, we've got here 180 plus an angle. 180 plus an angle is in the third quadrant, and tan is positive in the third quadrant. Therefore, we'll have tan of 30. It's probably a good idea to have your cast diagram open with you for this example. Also, what I do is at the beginning of a test or exam, I just write it at the top of my question paper in pencil so that I've got it with me for the rest of the test. So then you can have, let me just go back here. Tan of 180 plus 30, we said is in the third quadrant. Tan is positive in the third quadrant, so we're going to have positive tan of 30. Now we have sine of 180 plus an angle. 180 plus an angle is in the third quadrant. Sine is negative in the third quadrant, so it's going to be negative sine 60. Here we have sine 180 minus an angle. 180 minus is in the second quadrant. Sine is positive in the second quadrant, so we're going to have sine of 10, positive sine of 10. Ignore the scratch out for now, that was me simplifying. Then we have cos 90 plus 10. 90 plus 10 is in the second quadrant. Cos is negative in the second quadrant, so we're going to have a negative. But we have a 90 plus, so that's going to change to sine, and then we keep our angle of 10. Then sine of 180 plus an angle. 180 plus is in the third quadrant. Sine is negative in the third quadrant, hence the negative sign. So therefore, it's going to be negative sine of 45 degrees. Then lastly, cos, 180 minus an angle. 180 minus is in the second quadrant. Cos is negative in the second quadrant. Negative cos of the angle 45. Then we can cancel out our sine 10 and sine 10. Cancel out is probably a bad word to use. We're simplifying, we're dividing. Okay, we cross those out. Keep the negative sign over here. Then we can, this negative times this negative can cancel each other out to be a positive, and this negative divided by that negative will cancel each other out to become a positive. So we know everything, we can work with positives now. Now with our special angle triangles, tan 30 becomes 1 over root 3. Negative sine 6, there's no more negative now, so it's just sine 60 becomes root 3 over 2. Sine 45 becomes root 2 over 2. And cos 45 becomes root 2 over 2. This simplifies to a half over 2 over 4, which then simplifies to 1. Then our last section. This is one method of working out general solutions when solving equations. There is another method. Another tutor will post a video on the second method. This is generally what the CAPS syllabus uses. However, some CAPS schools do use the other method as well. But here is an example of how to solve an equation using general solutions using the reference angle formula. So here we are given that sine x equals negative cos x, and they've asked us to solve for x using the general solution. What we're going to do is we're going to take our cos to the other side. It will become sine x over cos x equals negative 1. We know that sine x over cos x is tan x, so we sub that in. So now tan x equals negative 1. We now can find our reference angle. Once we have a single trig ratio equals a number, we can move on to reference angle. In order to get our reference angle, we say shift on our calculator of whatever the ratio is. So for example, here it's tan, so shift tan of the positive of whatever this number is. So shift tan of positive 1. We're going to get 45 degrees. Now the sign comes into play. In our cast diagram, tan is negative in the second quadrant and the fourth quadrant. So now we write whichever is relevant, what quadrants are relevant to tan being negative. So if tan is equal to negative, we'll have quad 2 and quad 4. We then write down the rule for quad 2 and quad 4. The rule for quadrant 2 is 180 minus theta. Theta is 45. So we're going to have x equals 180 minus 45 plus 180k. K is an element of z. This is just an always thing that you write. If you have sine or cos, you write 1 plus 360k. But because of tan's restrictions, we have plus 180k. Then the rule for quadrant 4 is 360 minus theta. So we're going to say x equals 360 minus 45 plus 180k. K is an element of z. If this was sine or cos, we would have used plus 360k. We then simplify it to be x equals 135 plus 180k. K is an element of z. And x equals 315 plus 180k. K is an element of z. Now, if they just wanted the general solutions, we stop here. If they wanted the final answer or the final value for x, we go and sub values in to k. So if k is equal to 0, we start there. So now they've said that it must be between negative 180 and 360. So we sub in 0. If we sub 0 into k over here, we're going to get 135. If we sub it in here, we're going to get 315. Then we go to negative and positive 1. Then you go negative and positive 2, negative and positive 3, and until there are numbers that stop working. Okay. So now we're going to use negative 1. If we sub in negative 1, we're going to get, in here, we're going to get negative 45. If we sub in negative 1 over here, we're going to get 135. Then we move on to 1. If k is 1, if we sub it in here, we're going to get 315. If we sub it in here, we're going to get a value that is too high, and that is out of the restriction. Then we know we need to stop. So now x will equal negative 45 degrees, 135 degrees, and 315 degrees. Note that these are starting to repeat. That's when we know we are close to the end of our subbing in. And that is all for our trig part 1 video.